Okay, this is question 6 from January 2022 P1 question. These questions always scare me a little bit, I must admit. You should recognise these if you've been going through doing past papers, in that the variety of the different things that they can give me here means that I really need to have a good understanding of the topic as a whole when you're going through and doing it. Here we're going to have some integration, we've got an equation of tangent and normal, so some differentiation stuff. But let's jump in and see what we've got. And as I say, you probably need to do these in a cluster of questions to see, get a bit more experience at them. So this one says f dash x is equal to x plus 3 squared over x root x, right? Okay, whatever. Tells me a point and then tells me for part A, part 1. Well, that's straightforward enough now that I've read it. A part 1, if I want to find the gradient at P, I just want to find the gradient when x equals 4, and the gradient is f dash x. So if I've got that f dash x is equal to x plus 3 squared over x root x, what I'm looking out for, the gradient at P is just going to be f dash 4, which is equal to, just take your time and do it, but you can just plug all this in, 4 root 4 there. That's actually going to be quite tidy when we work it out. I've got 7 squared, 49 over 8 there. So that's the gradient. That's first part done. That's A part 1. A part 2, hence find the equation of the tangent at P. Okay, giving your answer in the form of ax plus by plus c equals 0. Put a little asterisk by that when you're doing the question so that at the end, we've got a couple of minutes worth of work to do here. You don't then forget when we're doing it. Okay, the equation of a tangent is a straight line. So if it's a straight line, I'm going to use y minus y1 equals m, x minus x1. And in this particular question, we've got that x1 is equal to 4, y1 is equal to 20, and m is equal to 49 over 8. Sorry, handwriting. 49 over 8 there. This is a nice little technique to get used to doing. Shows the examiner what we've got. We can just quickly check and then we won't make any errors when we're substituting in, hopefully. So chucking all that into the formula there, I've got y minus 20. I've got 49 over 8, x minus 4. And at this stage, don't mess about with this. Just multiply that number up. Often we're going to have a fraction there because of tangents and normals and whatever. Try and get into a nice routine that always works here. If I multiply everything by 8, it's not complicated to do that. And then, well, you can leave this for the first line if you want to, or you could do multiplying the 49 out straight away. But 8y minus 160 is equal to, yeah, multiply out that bracket as well. And sometimes it might be a negative there. It's not in this case, but just to stop us from making any silly mistakes when we're doing it. And at this stage, if you did have that asterisk, it reminds you of what we're doing. We don't necessarily need to always have y equals mx plus c at P1 level. So this is much neater to be able to write this as, I'm going to write it with the x positive. So I'm going to put 49x minus 8y and minus 36 equals 0. I'm actually taking everything over to that side. No reason why you can't take everything over to the other side. There's two alternatives. We could have had minus 49 plus 8 and plus 36 equals 0 would give us the same answer. Again, that one's finished. Just check that I've got what they asked me to do. Yep, done that. And then part B. Part B says find fx. So in other words, find the integral of f dash x, which was x plus 3 all squared. So let's write what we're doing here. I've got f dash x was x plus 3 all squared over x root x. And so fx is going to be the integral of that thing. Again, I want to get my marks here, so let's try and keep everything accurate in terms of dx's, etc., etc. Right, I can't integrate this yet. I've got to multiply out that bracket and I've got to tidy up the bottom bit. Do both of those at the same time. Multiplying out that bracket, you can go away and take your time to do that if you want to. At our level now, by the time you got to the exam, that shouldn't cause you any problems. You can check it compared to mine. And x times the square root of x is x times x to the half, and then you add the powers. So that becomes x to the 3 over 2 dx. Still can't integrate it. This is a good idea about keeping this integral sign in, is I'm making it clear to the examiner I haven't started yet. If you want to do it slowly, you can do each bit separately as divided by x to the 3 over 2. There'll be a lot more confident mathematicians here, though, that just do it all and miss that last step out. But x to the 2 divided by x to the 3 over 2, take away the powers, so we're going to get x to the half. Same thing with the next one, we're going to get 6x to the minus a half. Not only do I not make a mistake, that doesn't surprise me, they're going to want to give me a range of different questions here, aren't they? So when I get all those different things there, yeah, that's a fairly substantial integral to be able to do here now, so doesn't make any surprises to me when we're doing it. Integrating, I'm going to integrate now, so if I'm integrating, add 1 onto the power, so if I add 1 onto the power, I get x to the 3 over 2. You can do dividing by 3 over 2 if you want to do it quickly and say timesing 2/3. That's the same thing. Add 1 onto the power, gives me x to the half. Actually, dividing by a half is the same as timesing by 2, but there's nothing wrong with mixing up your methods for doing that. If you think that's going to be more complicated, and certainly like with this last one, for example, plus add 1 onto the power is going to give me x to the minus a half, and then divided by the new power is going to give me that version there. Sorry, I should really have my fx equals for all of these ones, so let me just go through and put that in. fx equals, fx equals, fx equals. So now, tidying that up is, 2/3 x to the 3 over 2 plus 12 x to the half minus 18 x to the minus a half plus c. So at this stage here, we've got the information from the original part that we knew that when, back up here, we know that when x is equal to 4, y is equal to 20. So that means I can actually work out what c is going to be. F4 is equal to 20. So that means that 20 is equal to 2/3. 4 to the 3 over 2 plus 12 lots of 4 to the half minus 18 lots of 4 to the minus a half plus c. And again, in terms of the brevity of this, I'm going to give you time to work that out for yourself. C actually works out to be equal to minus 1/3 if you just take everything over. So my final answer then, fx equals, well, I had just a second to go, but instead of having c now we have minus 1/3. Okay, hopefully that makes sense.